think, and then you want to divide that by 1.
So 3.82 times 120 divided by the 1 1/4, or 1.25 if you want to convert to decimal.
367 rounded up.
Giving us 367. No. I punched in some. Oh, I put 3.86 instead of 3.82, didn't I? Let me try that again.
We are all humanities.
367 when you round it up. You're right. Not bad, huh? We're getting good at those? Okay. Well, then the next thing I want to try, I'm switching over here. Okay, so we've been looking at the angles a little bit. We can read the universal bevel protractor, which is a good start. I want to take a look now at some of the relationships with angles. We did some operations with adding, subtracting, multiplying, dividing, and stuff. One relationship we talked about was complementary angles. Anybody remember what complementary means? Yes, sir. Oh, it's not coming up. Anybody remember what complementary means? They add up to 90. Yeah, complementary means we have two angles that add up to a square corner or a right angle. So if I have an angle that is 41 degrees, its complement would be the angle that would add to that to add up to 90, which would be how much? Yeah, 90 minus 41 is going to be 49 degrees. Well, let's find the complement of 37 degrees, 15 minutes, 47 seconds. How would we go about doing that? Well, this is what you were bringing up, Jason. We need the 0 minutes, 0 seconds. And in this case, we have to. So we're going to have 90 degrees, 0 minutes, 0 seconds. 37, 15, 47. And of course, we cannot subtract 47 from 0, so we have to borrow. But in this case, there's nothing here to borrow from, so we're going to have to go all the way up to the degrees. This will be 89 degrees. This is going to be how much? 60, but then we're going to borrow from that to make it 59 minutes, and this will now be 60. And now we can subtract. 60 minus 47 is 13 seconds. 59 minus 15 is 44 minutes, and 89 minus 37 is 52 degrees. So in your notes, find me the complement of 68 degrees, 51 minutes, 13 seconds. Okay. So we borrow again, 89, 60, borrow, we get 59 and 60. Now what? Got everybody at once. You get 47, okay, and 8 and 21. Good. How many of you had that? Okay. What's it change when I ask for the supplement? What does that mean? We're looking at 180 degrees instead of 90 degrees. So this would be 180 degrees, and again, we still have to add in 0 minutes, 0 seconds, and subtract 111, 29, 32. Walk me through it. Tell me what to do.
Borrow from the 180 or the 109 from 60 in the first column.
Okay.
Put 60 in the second column. 60 minus 32.
28.
59 minus 29 for 30, and then 179 minus 11.
Perfect. So 68 degrees, 30 minutes, 28 seconds. So let's have you find the supplement of 61 degrees, 43 minutes, 18 seconds. So again, we add in the 180 degrees, 0 minutes, 0 seconds. And we're going to subtract. Talk me through it. Let's see. Put in your calculator and I do it. So, okay, so we'll borrow from the 180, 179. This is going to become what? It'll become 60 first, and then we borrow to make it 59. And this will be 60. Okay? And then here we get 42. And here? 16 and 118. Works for me. How many people had that? Good deal. Well, we also dealt with problems where we had things like this. Pretend those lines are straight. Where this might be listed as 37 degrees, 19 minutes. This one in here, 32 degrees, 41 minutes, 18 seconds. This one down here, we'll call it 36 degrees, 49 minutes, 52 seconds. And I want to know what that angle is. How do I find it? Okay, so how do I write that out?
37 degrees, 19 minutes. 32 degrees, 41 minutes, 18 seconds.
Okay.
36 degrees, 49 minutes.
Perfect. And I'd probably put in 0 seconds up here just to fill in the missing spot. 0, 18, and 52 is 70. What's wrong with that?
Mine's over 60.
Over 60. So we're going to carry the 1 minute, and we're going to keep how much is left? 10 seconds. Good. 1 and 19, 20 plus 41 plus 49, 110. So what? Okay, so we're going to carry 1. We take 60 out of that. We're left with 50. 37 plus 1, 38 plus 32, 70 plus 36. So it's 106 degrees, 50 minutes, 10 seconds. Everybody doing okay? How about this one? I want to know this angle right here. What would I do there? Okay, I could add these all up and subtract from 360. So what am I going to do? Talk me through it. $17.38, okay. 19 seconds, 43 minutes, 19 seconds, yeah. So 90 degrees here, 0 and 0. Okay, so 38 and 19, 57. 17 and 43. 60. What's that mean? 0, and we carry the 1 degree. So we have 83, 19 makes 102 plus 90, 192. Is that our answer? Subtract that from 360. So we have to put in the 0 minutes, 0 seconds. And unfortunately, we got that 57 seconds sitting out there, so we're going to have to work with it. Borrow from the 360, 359, that'd make this 60. Borrow from that, 59 and 60. And we subtract. This is 3. This is 3, 59, and what's that? 160, 167. Oh, this should be 92. There we go. That makes more sense. How we doing? Okay, so, you got a question? Okay, so now that we've been talking about these angles, let's take a look at some other relationships we can run into. For example, we've already kind of ran into, for our supplementary and complementary, the idea of two adjacent angles having to add up to a total. If I tell you that this angle here is 88 degrees, 47 minutes, and that the total angle is 121 degrees, 12 minutes, we can find this missing angle over here by doing what? Just subtracting. Because we know that when two angles share the same vertex and they share one side, that they're additive. They add up to a total. So this would be 121 degrees, 12 minutes, minus 88 degrees, 47 minutes. Because we know that those two smaller pieces have to add up to the larger angle. So let's subtract. Tell me what to do.
First things first, you have to borrow from the degrees on the 121.
Perfect. That's 120. This is going to be
72.
We borrowed 60, so that's 72. Good.
Maybe 47 out of 72, 25.
25
88 out of 128.
is 32. So there we go. Well, our next step then, we mentioned briefly, angles like this. If this angle here is 37 degrees, 41 minutes, 19 seconds. What's this angle over here have to be? Okay, how do we come up with that? Okay, something we call vertical angles. There's two ways of looking at it. One is, you could look at it as the two lines started out on top of each other right here. And then one of them was rotated around this center of rotation. Well, whatever it rotates here, it has to rotate the same amount here. And if we use that definition of an angle as a measure of rotation, what fraction of a full turn it is, it has to rotate the same on both sides. The other way we could look at that is we look at it in terms of those adjacent angles. We know that this angle and this angle have to add up to a straight line, or 180. So if we did 180 degrees minus the 37 degrees, 41 minutes, 19 seconds, we get 41 seconds, 18 minutes, and 142 degrees. So we get this angle here, which means it has to be supplementary with this angle, so we have to subtract from 180, which gets us right back to where we started, the 37, 41, 19. So there's a couple of different ways of looking at it, and no matter which way you do it, those vertical angles have to be the same. The word we use is congruent. These are equal in every possible way. Well, now that we have those two rules established, the supplementary, complementary, and the vertical angles and all that, now we can look at something a little more complicated. What happens when we have more than two lines interacting? So we start out with our basic two lines, like this. In this case, we have two lines that have no special relationship. The term we're going to use for that is oblique. Remember, we have two special relationships. Parallel, which means what? So everybody's going to want to say they never intersect, but there's a little bit more technical meaning than that.
They're equal spaces.
Always the same distance apart. Equal spacing apart all the time. Good. And then there is perpendicular, which means, well, not only do they cross, but they cross at 90 degrees, a right angle. In fact, perpendicular is a little bit stronger than a right angle. It means it forms a right angle in every possible direction that you can measure. In this case, it's neither one, so everything else is classified as oblique. If I take these two lines and I cut them with another line, that third line is called a transversal. Now in this case, where it's cutting across two oblique lines, there's not really much of a special relationship going on there. Where it gets interesting is when we have two lines that are parallel. And I'm going to cheat to make my parallel lines, because I'm not really good at making lines parallel on the screen. So we have two lines that are parallel. If I run a transversal across the two of them, now we have some really special relationships. First of all, there are 8 angles formed here. To define all 8 of them, I only need to define one. If I define this angle here as 79 degrees, 14 minutes, 31 seconds, I've defined every angle there. How big does this angle here have to be? 180 minus, you got it, they're supplementary. Oops. So the 180 minus the 79, 14, 31. Of course, we're going to have to borrow again. I'm going to cheat and just put in 59 there instead of reborrowing. We get 29 seconds, 45 minutes, and 100 degrees. What's this angle here have to be? Perfect. It is a vertical angle from that one. So it's 79, 14, 31. Or we could say it's supplementary with this one here. So you subtract 180, you get the same thing. This one up here.
It's got to be 100 degrees, 45 minutes.
Perfect. 145.29. Down here, if I look at it, if I were to take this line, I could slide it down and lay it on top, and what happens to all the angles? They stay the same. They lie exactly on top of each other as well. So all the angles down here are the same as all the angles up here. There we go. We found all the angles. Don't you wish it was that easy on your homework? If this were a formal geometry course, we would be talking about all sorts of relationships, all sorts of rules, parallel line, transversal theorems, and all that wonderful stuff. We're not really into the vocabulary here, and it's not a formal geometry course. You need to know how to work with this stuff, not how to define this stuff. There are all sorts of special relationships in the angles here. There's something called corresponding angles, where this angle and this angle are called corresponding. You don't need to write this down. I'm just going to list it here for you because you might see the terminology in your packets. Yeah, they're the corresponding angles because if I take this line and I lay it on top of that one, those are the angles that are going to lie on top of each other. So they're corresponding. There are interior angles. Where do you think the interior angles are? on the inside, between the parallel lines. Well, interior angles themselves aren't that interesting, so they have special pairs. There are alternate interior angles. This angle here and this angle here are called alternate interior angles because they're on the opposite sides they're on alternate sides of the transversal. They're interior, but they're on alternate sides.
Now you think both contradicting angles?
Contradicting angles. In your world, I'm just there's a lot of those. Of course, what would be the relationship between these alternate interior angles? They would be equal. Of course, this angle here and this one here would also be a set of alternate interior angles. Since we use the word alternate, we could have exterior angles, which obviously are outside the parallel lines. What would be the alternate exterior angle to this one here? Right down here. It's on alternate sides of the transversal, and it's on the exterior. What do you think the relationship between those is? They're the same, yes. Then we have what's called not just corresponding angles, but corresponding interior and corresponding exterior, because they're on the same side of the transversal. Like this would be a corresponding interior angle to this one. Now those are obviously not equal. They're going to be 180, supplementary. Corresponding exterior angles would be these two. Again, they're going to be supplementary. Well, rather than memorizing all these rules of alternate interior angles are congruent, alternate exterior angles are congruent, corresponding interior angles are supplementary, and all that stuff, you know I've been trying to make my claim to fame, so we're going to do it right here. So Hoff's rule for parallel lines cut by a transversal. Write this one down, pass it on to your children. Hopefully it'll catch on and I'll be famous in a couple hundred years. When you have parallel lines cut by a transversal, all angles are either equal or supplementary, period. There's only two angles formed. No need to have all the other rules memorized. Because of this, there are a lot of interesting applications that come into machining applications that you might run into in a blueprint. Let's say we have a triangle like this. And one thing you guys deal with is cutter comp, right? Your cutter offsets. So let's say because of your cutter, you have to move this side here out 3/8 of an inch. If this angle in here is, well, let's do this one first. We'll do this one over here. Let's say this angle here is 57 degrees, 53 minutes. This angle down here is going to be 71 degree, 42 minutes. First of all, can we find this angle here? How do we find it? All right. We know the three angles of a triangle add up to 180. So we add those two up, we're going to get 95, which of course is 35, carry the 1. That's 8, and 1 is 9. 129. So 129 degrees, 35 minutes. How do you find this one then? Subtract from 180. So we borrow again. This is 25 and 50. Okay, so we've got all the angles in the original triangle. So then we do our cutter comp. We do our offset for the cutter. And now we need to know this angle and this angle. How do we find them? Yeah, because of what we just learned about parallel lines, this is basically, if we extend these out, this is a transversal cutting parallel lines. This angle and this angle must be the same. This angle and this angle must be the same. So it doesn't change anything. In fact, we can have a triangle. And let's say it's just a matter of changing your home point on your program. You're moving, you're moving your origin and you're reprogramming. So now let's say that this side's parallel to this side. This side's parallel here, and then this last side here is parallel. If I know my angles, I'm just going to fill in 2 of them here so I don't have to do the math. So I know those 2 angles. So I call these angles 1, 2, and 3. Which angle up there has to be 73 degrees 12? Number 1. Very good. How about the 58? Angle 3. When all sides of a triangle are parallel to the sides of another triangle, the angles are going to be the same, period. Now, that doesn't mean I can't say that these triangles are the same to each other. The angles are the same, but the triangles themselves are not necessarily the same because they can still be parallel and the sides be different lengths. I could push this side here all the way out here. It's still parallel. It's just the triangle's now bigger. So being parallel, having the parallel sides only guarantees the equal angles. Now the other thing we can do is this. If I put a side in here that is perpendicular to this one, let's do one here perpendicular. And we'll draw a side up here that's perpendicular. This triangle that's formed here, obviously it's a different size, but once again, the angles are going to have to be the same. Now, this one's going to be a little bit tougher to pick out. So I'm going to label this angle A, B, and C, 1, 2, and 3. 2 goes with what? With A, okay. 3 is definitely a C. That's the easy one to pick out. Yep. 1 would be left with B. Okay. If, in this case, they're a little bit obvious, but if they're not, you'd have to go through the math and you'd have to work it out. This here is 90 degrees. If you know, I didn't put any numbers in here, so we can't go through the calculations. But you know this angle here, you know this is 90 degrees. You can find this angle here. If I have a 4-sided figure like that, where I know 2 of the angles, we said triangles have to add up to 180. One of the things we're going to find, and we're going to look at a formula that tells us what is the angle sum of any figure. One thing we'll find, a 4-sided figure, the angles have to add up to 360 degrees. So if I have 2 right angles, I have 90 degrees and 90 degrees. How much is left? 180. So if this angle here happens to be 86 degrees, 29 minutes, what's this one down here going to have to be? Yeah. 180 degrees are left, so we're going to subtract. That's going to give us, yeah, it's the supplement of the 86.29, or 95 degrees and 31 minutes. What do you think? Okay, if you do me a favor and check in your current packet, I believe I've got to give you a new packet here. Is page 281 in the packet you currently have? I don't think it is. You have it? Oh, cool. 281, numbers 1 through 12. We'll have your work on those. All of them, yep.